Good morning, dear students. In the previous sections, we were discussing about what are the practical applications of this potentiometer. So in that one, the first practical application which we were seeing as a comparison of EMF of two cells that we discussed in the previous sections only. So here in today's section, we'll start with the second application of this potentiometer, which will be taken as to determine internal resistance of a cell. So you are going to use a potentiometer in order to identify what is the internal resistance of a given cell. So what amount of cell you are going to observe here, so what amount of internal resistance it is having, that you are going to determine by the application of a device called as potentiometer. So this is the practical application which will be taken as a second practical application here. So in order to understand this one, the same what you are observed in the previous diagrams, the same you are going to observe a circuit diagram like this. In that one, again you have taken this as initial point A, where you are going to apply positive terminal of a battery or as positive terminal of source of a potential. So when we apply positive terminal of this source of a potential, this point A will be taken as higher potential. So now you are going to observe it will be in a higher potential value. Similarly, when we observe, so this terminal or this end B, what you are observing, it is in turn connected to the negative of a battery, so that we can say here it is of lower potential. So you are going to observe a lower potential, and AB what you are observing, it appears as a single wire, but it is not a single wire. It consists of 4 wires which will be taken as a single wire here. So it means potentiometer. So in the construction of this potentiometer, we have observed, so it is having 400 centimeter wire. So in that one, we are going to assume this as a single wire which is giving the same amount of effect as that of the meter bridge here. So this is what we observed in the previous sections only. So in the previous sections we have taken 2 cells because we are making a comparison there. So because of that one we have taken the 2 cells here in that section, but here we have taken only the single cell which is having EMF value of E here, and it is having a resistor value of R. So it is having a resistance value of R here. So we are going to make a now amount of electric current flowing through in this direction when it comes for point A. Now in that one, again as that of the previous, we are going to follow 2 steps here. The same what we have observed in the previous, we are going to observe the 2 steps. The first one what you are observing here, this will be taken as switch S1. So here this is switch S1 here, and similarly here what you are observing, switch S2. So in the first step, so as that of the previous, so previous already observe ಮಾಡಿದ್ವಿ. So step 1 ಒಳಗೆ ಏನು observe ಮಾಡಿದ್ವಿ ನಾವು, switch S1 ಅನ್ನು close ಮಾಡಿದ್ವಿ. So you are observing switch S1 is in the condition as a closed here. So you are going to observe if S1 is closed like this, whenever you are going to make this switch as closed like this, what happens here, whatever the amount of electric current drawing, it is not at all moving through this resistor. So it is not at all moving through the resistor what you have taken as R here. So it is not moving through this resistor, but the thing is whatever the entire amount of electric current, that is entirely flowing through this EMF of a cell. So in the first step, that is the reason we have taken S1 as closed state, and the second switch what you are observing, S2. So the second switch what you have taken, it is in the open state now. So it is opened. So if you are going to observe open state, so it is what you are observing, we are not drawing any amount of electric current by this resistor. ಯಾಕಂತಂದ್ರೆ ನಾವು ಸ್ವಿಚ್ S2 ಕ್ಲೋಸ್ ಮಾಡಿಲ್ಲ ಅಂತಂದ್ರೆ ಯಾವುದೋ ಅಮೌಂಟ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ಏನಾಗಿಲ್ಲ ಈ ರೆಜಿಸ್ಟರ್ ಥ್ರೂ ಪಾಸ್ ಆಗಿಲ್ಲ. ಸೊ ಅದಕ್ಕೆ ಏನಂತ ಹೇಳ್ತೀವಿ, ಇಟ್ ಈಸ್ ನೋ ಎಲೆಕ್ಟ್ರಿಕ್ current drawn. So when no electric current drawn, so this is no electric current drawn by resistor. So it is not drawing any amount of electric current here. Whenever any circuit is not possible to draw any amount of electric current, we can say it is in the condition of open circuit. So this we observe as open circuit. Whenever we have the open circuit, we can say, or else we can consider EMF of a cell only. So we can consider EMF of a cell only. So that also we discussed in the previous section only. So what is the meaning of EMF of a cell? What is the terminal potential difference when this EMF of a cell exists here? What are the conditions for this EMF of a cell? Everything we discussed in the previous sections only. So just I'll remember, I'll glance once over on this one. EMF of a cell in the sense, remember, it is potential difference, not an electromotive force. It is also a potential difference whenever there is no amount of electric current drawn by any circuit. Whenever there is no amount of electric current drawn by the circuit, so that kind of potential difference developed in the circuit we call as EMF of a cell. So now by the principle of potentiometer we can write, so E is equals to, so we have E is equals to, so we can say, so this is K into L1. So this L1 got by the condition as, so L1 represents balancing length. So this obtained by the condition. So this is called as a balancing length here. So L1 is balancing length in the sense it is obtained by the condition of, so this is balanced here. So this is obtained by the condition. This what we have taken as a jockey. So yavagena jockey na observe ಮಾಡ್ತೀರಿ. So ಅಲ್ಲಿ ಗ್ಯಾಲನೋಮೀಟರ್ ಒಳಗೆ, ಸೊ ಗ್ಯಾಲನೋಮೀಟರ್ ಒಳಗೆ ಕರೆಂಟ್ ಏನಾಗಿರುತ್ತೆ, ವ್ಯಾಲ್ಯೂ 0 ಇರೋದನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ. ಸೊ ವಾಟ್ ಎವರ್ ದ ಅಮೌಂಟ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ಥ್ರೂ ದ ಗ್ಯಾಲೋಮೀಟರ್, ಆರ್ ಎಲ್ಸ್ whenever you are going to observe the amount of electric current through the galvanometer value as 0, it means the galvanometer, if it is going to show a value of 0, it means balanced condition arised. So whenever you are going to observe balanced condition arised for this particular length, so that particular length we call as a balancing length. So that particular length what you are observing, that we call as a balancing length here. So it is obtained by the condition of current through the galvanometer as 0. So when it is going to give the current as 0, whenever balanced condition, so whenever balanced condition is there, so in that cases we are going to observe current through the galvanometer value as 0. So whenever the balanced condition is there, we can say without drawing any amount of electric current, we are going to observe the equation E is equals to K into L1. So E is equal to K into L1 here. So this is the first step. We are going to observe only the EMF of a cell. Yes, you are going to observe only the case EMF of a cell. So after getting the step 1, now you are going to move towards the second step. So what happens? So what happens in that circuit? So now you are going to discuss about the second step. So when we consider the second step here, so in that one again the conditions or else the procedures follow same. So second step again observe ಮಾಡ್ತೀರಿ ನೋಡಿ. So second step again observe ಮಾಡ್ತೀರಿ, the switch S1 was previously closed. So first step again ಮಾಡಿದ್ರಿ, S1 ಅನ್ನು close ಇಟ್ಟಿದ್ರಿ. Here also we will keep switch S1 as closed only. So there is no change in the condition. You are going to observe switch S1 is closed only. So whenever you are going to observe switch S1 is closed, and what about the S2 switch? So second switch. So when you observe the second switch, here the second switch what you are observing in the previous first step, it was in the open condition, now it is closed. So here also this is closed here. So when we both switches are closed here, what happens? Whatever the amount of electric current entering from this point A, so whatever the amount of electric current entering from this point A, a part of current is flowing through EMF of a cell and the remaining part of electric current is flowing through the resistor. So remaining part of this electric current is flowing through this resistor. So whenever the part is going to through this one, we can say current drawn by, so current drawn by a resistor here. So current drawn by a a resistor, it implies current drawn by circuit. So current drawn by a circuit here. So whenever current is drawn by the circuit, there is no existed quantity of EMF of a cell. There is a existed quantity of terminal potential difference. So terminal potential difference arises. So very important fact here, because what you are observing, switch S1. So switch S1 as well as switch S2, both are closed here. When both are closed here, a certain part of electric current is going to flow through this resistor. It means it is going to drag certain amount of electric current from the EMF of a cell. ಅದಕ್ಕೆ ನಾವು ಏನಂತ ಹೇಳ್ತೀರಿ, current drawn by the resistor ಅಂತ ಹೇಳ್ತಾರೆ. ಯಾಕಂದ್ರೆ ಇದು ಡ್ರಾಗ್ ಮಾಡ್ತದೆ, ಸಡನ್ ಅಮೌಂಟ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ಏನ್ ಮಾಡುತ್ತೆ, ಡ್ರಾಗ್ ಮಾಡುತ್ತೆ. ಡ್ರಾಗ್ ಮಾಡೋದ್ರಿಂದ ಸೊ ಯಾವಾಗ ಇದನ್ನ ಡ್ರಾಗ್ ಮಾಡ್ತೀರಿ, ಸೊ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಸರ್ಕ್ಯೂಟ್ ಒಳಗೆ ಏನ್ ಫ್ಲೋ ಆದಂಗ ಆಗುತ್ತೆ, ಈಗ ಕರೆಂಟ್ ಫ್ಲೋ ಆದಂಗ ಆಗುತ್ತೆ. ಸೊ ಕರೆಂಟ್ ಡ್ರಾನ್ ಬೈ ದ ಸರ್ಕ್ಯೂಟ್ ಅಂತ ಕನ್ಸಿಡರೇಷನ್ ಮಾಡ್ತೀವಿ. ಸೊ ಯಾವಾಗ ಕರೆಂಟ್ ಬೈ ದ ಸರ್ಕ್ಯೂಟ್ ಅಂತ ಹೇಳ್ತೀರಿ, ಸೊ ದೇರ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಅಬ್ಸರ್ವ್ ಟರ್ಮಿನಲ್ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್. ಸೊ ದೇರ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಅಬ್ಸರ್ವ್ ಟರ್ಮಿನಲ್ potential difference. So if you are going to observe terminal potential difference, how you are going to measure? So ಈಗ condition ಯಾವ ಬರೀತೀರಿ, so again you are going to move from end A to the particular end B like this. At this particular point you are going to observe current through the galvanometer as 0. So at this particular point of J dash, let us assume this J and let us assume this as J dash point. At J dash point, what you are going to get here, current through the galvanometer as 0. So at this J dash point here, so at point of J dash, you are going to observe current through the galvanometer value as 0. So when we observe current through the galvanometer as 0, we can say terminal potential difference is equals to K into L2. So K into L2 here, because in the first section we have taken EMF of a cell. In the second step we have observing this as a terminal potential difference, which is given by V is equal to K into L bar. Now you are going to get a internal resistance of a cell. So we have taken both the steps. After covering this both the steps, you are going to calculate what is the equation for this internal resistance of a cell. The equation corresponding to this internal resistance of a cell is given by R is equal to, so R is equal to E divided by V minus 1 multiplied by capital R. So this is the equation of this internal resistance of a cell. So how we got this one? Let us see. So ಯಾವ ರೀತಿ ಆ equation derive ಮಾಡಿರಿ ನೋಡೋಣ. So we have the equation V is equal to I into R. So this is the first equation. Or else consider the, okay, so this is the first equation. And the second equation, by the condition of electric current in terms of EMF of a cell, is given by I is equal to E divided by capital R plus small r. So consider this as equation number 2 here. So we will alter this equation number 2. So when we alter, we can write, so E is equals to, so E is equals to I multiplied by capital R plus small r. So this is the second equation which is altered in terms of EMF of a cell. So now we will divide second equation by the first equation. So when we divide second equation, or else consider this third equation, we will divide. So we will divide third equation by first equation. So when we divide third equation by the first equation, you are going to get the equation like this. So E is equals to I into R plus small r. So here capital R represents external resistor and small r represents internal resistance of a given cell. So ಯಾವ cell ಕೊಟ್ಟಿರುತ್ತೆ ಅದನ್ನ identification ಮಾಡಾತ್ರಿ. So I will divide it by the first equation. So what is the first equation here? The first equation you are going to observe V is equal to I into R. So just we'll write, so V is equal to I into R here. So here I and I get cancelled. So after making a cancellation terms, we can write. So this is given by E divided by V is equals to, so just we'll take a numerator terms and divide it by the denominator terms here. So after dividing, we can write 1 plus small r divided by capital R. So small r divided by capital R. Again the equation you are going to write. So this implies E divided by V. E divided by V minus 1. So is equals to R divided by capital R. So E minus this minus 1 is what we are observing here. We'll take it for the LHS terms. So when we consider here E divided by V minus 1 is equals to small r divided by capital R. So again this implies R is equal to capital R multiplied by E divided by V minus 1. So this is the equation of this, what you are observing directly as internal resistance of a cell. So the same equation we will written directly like this. So R is equals to E divided by V minus 1 into multiplied by capital R. So this is about the internal resistance of this equation what we are observing like this. ಇದನ್ನ ಸರ್ ನಿಮಗೆ ಜಸ್ಟ್ ಡೈರೆಕ್ಟ್ ಆಗಿ ನೆನಪಿಟ್ಕೊಂಡ್ರೆ ಸಾಕು, ನೀವೇನು ಡೆರೈವ್ ಮಾಡೋದು ಬೇಕಾಗಿರಂಗಿಲ್ಲ. ಸೊ ಯು ಹ್ಯಾವ್ ಟು ರಿಮೆಂಬರ್ ಡೈರೆಕ್ಟ್ಲಿ ಇಕ್ವೇಶನ್ ಲೈಕ್ ದಿಸ್. ಸಪೋಸ್ ನಿಮಗೆ ಗೊತ್ತಾಗಲಿಲ್ಲ ಅಂದ್ರೆ ಯಾವ ರೀತಿ ಬರುತ್ತೆ ಅನ್ನೋದನ್ನ ಈ ರೀತಿ ಇಕ್ವೇಶನ್ಸ್ ಜಸ್ಟ್ ನೆನಪಿಟ್ಕೊಂಡ್ರೆ ಸಾಕು. Now, so if you are going to observe internal resistance of a cell like this, so we have calculated what is the value of E and we have calculated what is the terminal potential difference as capital V. So when we calculated, so E was given as E is equal to K into L1. So this is the first or else step 1 condition. So ಯಾವಾಗ step 1 ಇರುತ್ತೆ ಆ step 1 condition ಇಂದ ನಮಗೆ ಎಲ್ಲಿಂದ ಬಂದಿತ್ತು? So step 1 condition ಒಳಗೆ ಈ equations ಅನ್ನು observe ಮಾಡಿದ್ರಿ. So E is equal to, so this is the first one or else the step 1 here. So in the first step we have taken the equation like this, E is equal to K into L1. Next, after getting this one, the second equation or else second terminal potential difference what we are observing here, that was given by V is equal to K into L2. So K into L2. So this equation or else the terms what you are observing here, that was obtained by the step 2 here. So the equation what you are observing, V is equal to K into L2. So this equation was obtained by step 2 here. Now, so we will substitute in the general equation of internal resistance of a cell here. So we will substitute in this equation. So when we substitute in this equation, we can write R is equals to, so R is equal to capital E value which is given by K into L1 and capital V value which is given by K into L2 minus 1 multiplied by capital R. So here K and K get cancelled. So R is equals to L1 divided by L2 minus 1 multiplied by capital R. So where L1 represents, so here what happens, L1 represents a balancing length. So it is called as a balancing length. ಯಾವ ಕಂಡೀಷನ್ ಒಳಗೆ ಬಂದಿತ್ತು ನೋಡ್ರಿ, ಸ್ಟೆಪ್ 1 ಕಂಡೀಷನ್ ಒಳಗೆ ಬಂದದ. ಸೊ ಸ್ಟೆಪ್ 1 ಕಂಡೀಷನ್ ಒಳಗೆ ಯಾವ್ದಿತ್ತು, ಸರ್ಕ್ಯೂಟ್ ಈಸ್ ಓಪನ್. ಸೊ ದಟ್ ಇಸ್ ದ ರೀಸನ್ ಬ್ಯಾಲೆನ್ಸಿಂಗ್ ಲೆಂತ್ ಆಫ್ ಓಪನ್ ಸರ್ಕ್ಯೂಟ್. ಸೊ ವಿ ಕಾಲ್ ದಿಸ್ as a balancing length of open circuit. And L2, so what you are observing, L2, again L2 is also the same value or else the same term we are going to call as balancing length. Balancing length of, now the circuit is closed here. So that is the reason we can say closed circuit. So balancing length of closed circuit here, because in the second step we have observed like this, a switch S2 as well as switch S1 both are closed. So when both are closed here, a part of electric current is drawn by this resistor. So part of electric current is drawn by this resistor here. So this is the equation corresponding to internal resistance of a cell. So in order to identify internal resistance of a cell, we are going to use this equation like this. So it has practical application also. We are going to observe in practicals also. This is about the internal resistance of a cell. So this completes our theory sections. So after completing these theory sections, we'll see what are the important formulas we got in this chapter. So I have an important chapter again, and formulas bandada a list of formulas and nodes. So very important here. So just have to mention what are the list of formulas. So list of formulas. List of formulae. So now the first formula we have taken I is equal to Q divided by T. So it means what it is? Flow of net charges. It is not a single charge. So flow of net charges during certain interval of time that we have taken as a capital Q. Or else this equation can be also written as I is equal to N into E. So N into E divided by T here. So here N represents number of electrons and E represents charge of an electron. So now the T term what you are observing, it is taken as a certain interval of time in order to make a crossover of these electrons from one end of a conductor to the another end of a conductor. That is also we discussed in the first concept of this chapter itself. Next, so after getting this one, now you are going to observe the second formula. So the second formula, that what you are observing like this. So electric current in terms of drift velocity. So electric current in terms of drift velocity, I is equal to NEA into VD. So VD represents drift velocity. So then what about the drift velocity expression? So Vd is equal to small e capital E tau divided by m. So this is so drift velocity is given by E into capital E tau divided by m value. So this is the expression for drift velocity. Next, so after getting this current in terms of drift velocity, we have taken what is the equation corresponding to the resistor. So R is equal to rho into L divided by A value, or else this rho also can be written as M divided by N E square into 2, or else this conductivity can be replaced as reciprocal of the resistivity, or else sigma is equal to, we can write N E square 2 divided by m value. So again the another format of this resistor as well as resistivity. So resistance as well as resistivity here. So after getting this term, we are observing the current density. So current density equation which was given by I divided by capital A. So here these two are in a vector form and I is, or else electric current is a scalar quantity. So that's the reason we can write, so I is equals to JA cos theta. So we can write I is equal to JA cos theta. So now again one more you are observing current density in terms of conductivity as well as in terms of electric field. The equation which is given by vector J is equals to sigma into vector E. So this is a relationship between current density, electric field as well as conductivity. Now, so after getting this equation, we have taken about the temperature dependence. So we have observed about the temperature dependence of resistance as well as resistivity. So resistance as well as resistivity. So temperature coefficient, we call this as a temperature coefficient, which is given by alpha is equals to delta R divided by R naught into delta T. So delta T represents change in the amount of temperature, delta R represents change in the amount of resistance, and R naught represents original resistance of a given material. So this is about the temperature coefficient. The same temperature coefficient we are going to observe it for resistivity also. So resistivity. So resistivity, here we have going to represent alpha bar. So alpha bar represents temperature coefficient of resistivity, so that we can write delta rho. So delta rho divided by rho naught into delta T. So this is rho naught into delta T. So where delta rho represents change in the amount of resistivity, whereas rho naught represents original resistivity, and delta T represents, so delta T in represent ಮಾಡುತ್ತಾ ಎಷ್ಟು amount of temperature change ಆಯಿತು ಒಂದು given material ಒಳಗೆ ಎಷ್ಟು amount of temperature change ಆಗೋದನ್ನ representation ಮಾಡಲಿಕ್ಕೆ delta T ನ equations ನ ಬರೀತೀವಿ. So this is about the temperature dependence of these materials on the properties of resistance as well as resistivity. So after getting this one, a very important formula which will be taken as V is equal to I into R, which is called as Ohm's law. So Ohm's law is applicable only when we have the temperature as constant value. So this is the equation what you are observing regarding Ohm's law. So after getting this Ohm's law, we were discussing about the cells. So when we were discussing about the cells, the amount of electric current in terms of EMF of a cell is given by I is equals to capital E divided by capital R plus small r. So this capital R represents external resistance and this small r represents internal resistance of a given cell. So this is the equation. And one more very important equation. So V is equals to capital E minus capital I into small r. So this capital V represents, so capital V represents whenever the amount of electric current is drawn by the circuit. So whenever the amount of electric current drawn by the circuit, that we call as terminal potential difference. So that will be taken as terminal potential difference. Next, what it is going to represent? So E represents not an electric field. This E represents EMF of a cell. So this is EMF of a cell in the sense it is also a potential difference whenever no amount of electric current is drawn by this circuit. Whenever no amount of electric current is drawn by this circuit, we will consider this as EMF of a cell. Next, small r represents internal resistance of a cell. So internal resistance of a cell here. So this is a very important equation. So whenever there is no amount of electric current drawn by the circuit, ಅಂದ್ರೆ ಏನು, suppose I value 0 ಆಯ್ತು ಅಂತ ತಿಳ್ಕೊಡಿ. suppose I value 0 ಆಯ್ತು ಅಂದ್ರೆ ಮೀನಿಂಗ್ ಏನು, ಯಾವುದು ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ಸರ್ಕ್ಯೂಟ್ ಒಳಗೆ ಡ್ರಾ ಮಾಡಿಲ್ಲ. ಸೊ ಯಾವಾಗ ಯಾವುದು ಅಮೌಂಟ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ನೀವು ಸರ್ಕ್ಯೂಟ್ ಒಳಗೆ ಡ್ರಾ ಮಾಡಂಗಿಲ್ಲ, ಅವಾಗ ಏನಾಗುತ್ತೆ, ಕಂಡೀಷನ್ ಏನ್ ಬರುತ್ತೆ, ಟರ್ಮಿನಲ್ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿಕಮ್ ಈಕ್ವಲ್ಸ್ ಟು ದ EMF of a cell if I is equals to 0. Again very important condition. So one more important condition, V is equal to I. So V is equal to I in the sense terminal potential difference of a cell itself is going to act as a EMF of a cell here. So it means whenever there is no amount of electric current drawn by the circuit, we can say terminal potential difference will be equal to the EMF of a cell here. So again these are one more important formula. Next, so after getting this formula, so you are going to observe one more condition. V is equal to capital R into capital E divided by R plus small r. Again it is one of the important formulas. So this is again terminal potential difference in terms of EMF of a cell. Next, so after getting these equations, we have observed about the resistors, we have observed about the cells, and we have observed about the Wheatstone bridge balancing condition, and we have observed about the meter bridge as well as potentiometer, and what are the applications of this potentiometer. So in that one we are going to observe resistors. So when we have the resistors, the series combination is given by Rs is equal to R1 plus R2 like this. So we have the n number of resistor. When we have the n number of resistor, we are going to observe a series combination is given by Rs is equal to R1 plus R2 up to the n terms. Next, whenever we have the parallel combination, so whenever we have the parallel combination, it is given by 1 divided by Rp is equals to 1 divided by R1 plus 1 divided by R2. Like this, again we have n number of terms here, so n number of resistors connected. When we have the n number of resistors connected like this, the parallel combination formula is given by 1 divided by Rp like this. Now, so one more important formula, when we have cells in series and when we have cells in parallel. So when cells are in series, the amount of electric current, so the amount of electric current when cells are in series is given by N into capital E. So N into capital E divided by R plus N into small r. So small r represents internal resistance of a cell, whereas this capital R represents external resistor which is connected to the combination of these cells, which is connected to this combination of these cells here. So you are going to observe cells in series. Whenever you are going to observe cells in series, this is the condition what you are observing. I is equal to N into E divided by R plus N into R. So here one more important here, R should be, so R should be always, this R should be always greater than internal resistor sum, the sum of internal resistors here. So external resistor ಏನು ಕನೆಕ್ಟ್ ಮಾಡಿರ್ತೀವಿ ನಾವು, ಆ ಎಲ್ಲಾ ಸೆಲ್ ನ ಕನೆಕ್ಟ್ ಮಾಡಿದಾಗ ಎಷ್ಟು ಇಂಟರ್ನಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಬಂದಿರುತ್ತೆ ಅದಕ್ಕಿಂತ ಹೆಚ್ಚಿಗೆ ವ್ಯಾಲ್ಯೂ ಇದ್ರಷ್ಟೇ ಈ ಅಪ್ಲಿಕೇಶನ್ ಅಥವಾ ಈ ಕಂಡೀಷನ್ ನಾವು ಅಬ್ಸರ್ವ್ ಮಾಡಬಹುದು. ನೆಕ್ಸ್ಟ್, ಸೊ ಆಫ್ಟರ್ ಗೆಟಿಂಗ್ ದಿಸ್ ಒನ್, ಅಗೇನ್ ವಿ ಕ್ಯಾನ್ ರೈಟ್ ಅಮೌಂಟ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ I is equals to E divided by, so E divided by capital R plus small r divided by N value. So now whenever the cells are in parallel, so whenever the cells are in parallel, we are going to observe this equation. So the same equation you are going to write another format like this. So I is equals to what we have, N into E divided by N into capital R plus small r. So just will make a alterating terms here. So this is about the whenever the cells are in parallel conditions. So after getting these cells are in parallel condition, one more is very important. What is the balancing condition of Wheatstone bridge? So balancing condition of Wheatstone bridge, which is given by P divided by Q is equals to R divided by S. So P divided by Q is equals to R divided by S value. So this is a balancing condition of Wheatstone bridge. So based on this balancing condition of Wheatstone bridge, we are going to observe practical application as a meter bridge. So when we observe the meter bridge, we can write R is equals to S into L divided by 100 minus L. So this is what we are called as R represents. So here R represents unknown resistor. So ನಮಗೆ ಗೊತ್ತಿರಲಾರದ ವ್ಯಾಲ್ಯೂ ಏನಿರುತ್ತೆ ಆ ರೆಸಿಸ್ಟರ್ ವ್ಯಾಲ್ಯೂನ ಐಡೆಂಟಿಫಿಕೇಶನ್ ಮಾಡಲಿಕ್ಕೆ ಈ ಫಾರ್ಮುಲಾನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಸೊ ಆ ಕ್ಯಾಪಿಟಲ್ R represents unknown resistor in the given meter bridge. Next, so after getting this one, you are going to observe a potentiometer. So in the potentiometer, so we have taken E1 divided by E2. So E1 divided by E2 is equals to L1 divided by L2. So what does it mean? So the meaning so E1 divided by E2 ಅಂತಂದ್ರೆ ಎರಡು ಸೆಲ್ ನ ಯೂಸ್ ಮಾಡಿರಿ. So both cells are having EMF value of E1 as well as E2 and the corresponding balancing length of first as well as second cell is given by L1 divided by L2. So now this is the equation. So after getting this one, what about the internal resistance of a cell? So internal resistance of a cell is given by R is equal to L1 divided by L2 minus 1 multiplied by capital R. So these are the some important formulas what you are going to observe. Based on these important formulas, you may get the theory based numericals. So you may get theory based numericals, and in this chapter, so very important is that one compulsory theory based numerical is there from this chapter. So it is a very important concept. So just go through the important list of formulas what we mentioned here. Okay, thank you.